Hello everyone and welcome to our new video, and today's video is about solving another polynomials. Solving a function and turning it into a polynomial, and which today's video's case is that will be a sin x. Here we have our function sin x, and since we want it to be equal to a polynomial, so we will set it to equal to polynomial's function, which is c sub 0 plus c sub 1 times x plus c sub 2 times x to the power of 2 plus c sub 3 times x to the power of 3 plus c sub 4 times x to the power of 4 and plus c sub 5 times x to the power of 5 and plus dot dot dot. And setting all of that aside, we will write our function sin x, and when the x is 0, we have our sin x 0, which is just 0, and then we will derivative our top function, so we have our f prime x is equal to cosine x, and x being 0, we have cosine 0, which is just 1, and then we derivative this function again. We have f prime x is equal to negative sin x, so f 0 is equal to just 0. Oh yeah, and I forgot my prime sign for the f0's function. And then we derivative this function, so we get f prime x is equal to negative cosine x. So f prime 0 would be negative 1. And we will derivative this function, so we get f prime. Actually, no, we will use our number notation. So we have f to the power of 4x, which is equal to back to sin x. So our f to the power of 0 is 0. Then we will derivative one last function, so we get f to the power of 5 x is equal to cosine x. So from the previous thing we wrote down, we have function, or f to the power of 5 0 is equal to 1. We will differentiate our original function. Then we have, actually no, before we do that, we will set x is equal to 0. So then we can have f 0 is equal to c sub 0, and from right here we have f0, it says that is equal to 0, so c sub 0 is equal to 0. We will now differentiate this function, so we have f prime x is equal to c sub 1 plus 2 times c sub 2 times x plus 3 times c sub 3 times x to the power of 2 plus 4 times c sub 4 times x to the power of 3 plus 5 times c sub 5 times x to the power of 5 and plus dot dot dot. Now we will set our x is equal to 0, so we have our f prime 0 then is equal to, just be left with c sub 1. And from right here, f prime 0 is equal to 1. So c sub 1 is 1. We will now differentiate this function. So we have f prime prime x is equal to 2 times c sub 2 plus 2 times 3 times c sub 3 times x plus 3 times 4 times c sub 4 times x to the power of 2 and plus 4 times 5 times c sub 5 times x to the power of 3 and plus dot dot dot. Now once we set our x is equal to 0, we have f prime prime 0, which is equal to 2 times c sub 2. And from right here, it says that f prime prime 0 is equal to 0. So 2 times c sub 2 is equal to 0. So c sub 2 is equal to 0. So now we will differentiate this function. So we get f prime 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 x is equal to 2 times 3 c sub 3 plus 2 times 3 times 4 times c sub 4 times x plus 3 times 4 times 5 times c sub 5 times x to the power of 2 and plus dot dot dot. Now we will set our x is equal to 0. So we have f prime 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 0 is equal to 2 times 3 times c sub 3. And from right here we have f prime 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 0 saying that it is negative 1. So 2 times 3 times c sub 3 is equal to negative 1. So c sub 3 is equal to negative 1 over 2 times 3. Differentiating this function, we get f to the power of 4 x is equal to 2 times 3 times 4 c sub 4 plus 2 times 3 times 4 times 5 c sub 5 times x plus dot dot dot. Now setting our x is equal to 0, we have f to the power of 4, 0, which then is equal to 2 times 3 times 4 times c sub 4. And from right here, f to the power of 4, 0 is equal to 0. So our c sub 4 is equal to 0. This will be our last time differentiating a function. So we will differentiate this function right now. So we have f to the power of 5 x is equal to 2 times 3 times 4 times 5 times c to the power of 5 plus dot dot dot. But setting our x as 0, all the plus dot dot dots disappear, so we are only left with 2 times 3 times 4 times 5 times c sub 5. And from right here, f to the power of 5, 0, it says that is equal to 1. So our c sub 5 is equal to 1 over 2 times 3 times 4 times 5. We won't be needing these notes anymore. From what we have here, we will just simply substitute them back into our original function. So we have our sine x is equal to c sub 0 is just 0, so we will not put anything there, and c sub 1 is equal to 1, so 1 times x is just x, plus c sub 2 is 0, so 0 times x to the power of 2 is 0, so we will put nothing there again, and c sub 3 is 1 over 2 times 3 times x to the power of 3. So we have x to the power of 3 over, oh, and I forgot the negative sign in front of it. So we have negative x to the power of 3 over 2 times 3. And plus c sub 4 is just 0. So 0 times x to the power of 4 is just 0. So nothing goes there. And we have our c sub 5, which is equal to 1 over 2 times 3 times 4 times 5. And times x to the power of 5. So we have x to the power of 5 all over by 2 times 3 times 4 times 5 plus dot dot dot. Just by reading our function, you can kind of see a rhyme going on, which we have positive, negative, positive. So then our next of plus dot dot dots, we will have a negative, then everything is by fraction. Notice how our power is being added by plus 2, so we will have x to the power of 7, and over here we have 2 times 3, and our next we have 2 times 3 times 4 times 5. So again, there are 2 numbers being multiplied from our first before one. So we have 2 times 3 times 4 times 5 times 6 times 7. Looking at the bottom numbers carefully, it is actually a what is it called? Oh, factorial. So we have x over 1 factorial minus x to the power of 3 over 3 factorial, and plus x to the power of 5 over 5 factorial, and minus x to the power of 7 over 7 factorial, and plus dot 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 because it goes on forever. And I accidentally erased the plus dot 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 from the top, which these are all is equal to sine x. So we just found our answer to our sine x, writing it as a polynomial. Bye. Thanks for watching. See you guys in the next video.